Hi, welcome to Code with Z. In today's video, we gotta add two binary numbers together. Why? Well, because that's what LeetCode 67 add binary is asking us to do. As you can see, it says, given two binary strings, A and B, return their sum as a binary string. All right, let's do that. But if we want to solve this, we have to understand three simple things. They're really simple. We only have to know these three things. So the first thing is, in binary addition, if we add 0 to 0, that's gonna give us 0. Right? And if we have 1 plus 0 in binary addition, that's going to give us 1. And the last thing is, if we have 1 plus 1 in binary addition, that's going to give us 1, 0, meaning we're going to have 0 and then we're going to have a carry. Now let's get back to this and solve this with the things that we just learned. So we say 1 plus 1, and we just saw that 1 plus 1 is going to give us 0 and a carry. So we're going to say 0 and a carry, like so, and then we have another 1 plus 1, as you can see. So that's going to give us 0 and a carry, and then we're going to bring this down, and that's going to give us this. And this is going to be our answer. As you can see, we start adding the numbers from the right side, not the left, and we just add them together based on the three simple rules that we saw. So for example, if we have this, we're going to again say 1 plus 1 is going to give us 0 and a carry, so 0 and a carry, but now we have 3 1s. Well, if we add these two together, that's going to give us 0 and a carry, right? But we also have another one. So we're going to say adding these two is going to give us 0 and a carry, but we also have a 1, so that's going to give us 1, and then we also have a carry. Simple as that. It's like saying add these two and then this one to it. So now we have this one here, and then we're going to bring it down, and that's going to be our answer. Simple as that. Now, we're just going to literally code this out right now. So let's code this in the simplest way possible. Alrighty, so the first thing that we need to do is to actually loop through our numbers from the left to the right. So we're going to define two variables. The first one is going to be called I, and this is going to be equal to the index of the last digit inside of our A number. And then we're going to have J, and this is going to be equal to the index of the last digit inside of our B number. And then we also need to have our result variable, and this is going to be an empty string because we were told that we need to return a string. Now we have to loop through our numbers. So we're going to say while I is greater or equal to 0 or J is greater or equal to 0, do the following. Now, why do we have this? Well, because, for example, maybe the length of our first number is greater than the length of our second number. And just because of that, we don't want to stop. We want to make sure that we actually go through all of the numbers. So we're going to say keep on looping and only stop when we're done with both of the numbers. And then here we have to get our numbers. So we're going to say const bit A, and this is equal to a condition. Why a condition? Well, for example, if our B number is greater than our A number, meaning in terms of length, meaning our B number is lengthier than our A number, when we keep on looping because of the length of our B number, our I is going to become less than 0 because in terms of length, A is smaller than B. So we need to make sure that we cover that edge case. So we're going to say bit A should be equal to if I is greater or equal to 0, meaning if we're still looping through the digits in our A number, if that's the case, bit A should be equal to A at the index of I. And if that's not the case, we just want to have 0. But remember, this is a string and we want a number, so we're just going to convert this into a number like this. And then we're going to have the same thing for bit B. We're going to say bit B, these are the numbers that we're going to add together. So we're going to say J being greater or equal to 0. If that's the case, we want to have this basically. And if that's not the case, just give us 0. We need to calculate our sum. So we're going to define a variable called sum, and this is going to be equal to bit A plus bit B plus, we saw in the slides that we had a carry. So let's define our carry here. We're going to say let carry, and that's equal to 0 because in the beginning, we don't have any carries. So it's going to be 0 in the beginning. Now that we have our sum, we need to add it to our result. So here we're going to say result should be equal to sum plus result. But we need to do this. Like, so we're going to say sum mod 2. Why? Well, because this is binary addition. For example, if our bit A is 1, and our bit B is 1, and our carry is 1, that's going to give us 3. But we only want 1 or 0 because this is binary addition. And modding it by 2 is going to take care of that problem. But remember, our result is a string. So when we actually do this, we got to convert it back into string like so. So we make sure we can actually add it to our result. And then we only have one more simple thing to do, and that's calculating the carry. And it's really simple. We're going to say math.floor sum divided by 2. Now, what does this mean? Well, for example, if our sum is 1, 1 divided by 2 is going to be 0.5, and this is going to be equal to 0 because we're getting the floor. So that means we have no carry. But let's see what will happen if we have a carry. So if our sum is, for example, 2, that means we need to have a carry, right? So we're going to say 2 divided by 2, that's going to give us 1, and our carry is going to be 1. Now, even if our sum is, for example, 3, if we have 3 ones being added up to each other, just like we saw on the slides, that's going to be 3 divided by 2, and that's going to give us 1.5. And if we get the floor of it, that's going to be 1. So we still have the correct carry. And that's why we have this here. And then at the end, we're going to decrement I and we're going to decrement j. So we actually loop through each number correctly and we don't end up with an infinity loop. And then at the end, we're going to return our result. But when we actually add the numbers together, in the last round, we might end up with a carry and we need to add it to our result. So we're going to say keep on looping as long as I is greater or equal to 0, or j is greater or equal to 0, or carry is greater than 0. Like so, and that's going to take care of that problem. Now let's run it and see if we're going to get accepted. I hope I have not made any typos. Let's see. Yep, we got accepted. That's awesome. Let's submit it. Moment of truth. Let's see if we're going to pass all of the test cases. Yep, as you can see, that's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.